Let's take the triangle inequality for any two vector A and B. Vector A plus vector B, modulus of it is less than or equal to vector A plus vector B. Let us see a picture of it before coming here. Here are two things, okay. Instead of vector, it's going to be vector x and vector y, or you can substitute instead of x, you can call it y, b a and b, okay. In this case, let's have it as x and y. When x vector x, modulus of vector x, and somewhere here, we don't know, yeah, here, somewhere here, okay, it intersects. Green area this is vector y, and this is going to be vector x, okay. So this and this, the modulus is nothing but magnitude or length, whatever you can assume, okay. So very easily we can say this x plus y equal to, when it is linear, it's going to be sum of this portion plus sum of this portion, right? This is when it is linear or in one single line. Take this case. Here we have, the vector is going to be starting from here till here length, okay. So we call this vector x, right? So this one is going to be what? From here till here, we call it y. So when it is x plus y, if this point, if you try to bring it down here, the projection of this would be here and projection of this would be here. There would be a subtle overlap. So this length is bigger, this is bigger, this plus this is bigger than the sum of this. That is what we are trying to say here. You know what is said here is, when it is linear, the sum is equal, right? When it is bigger, it is obvious, since this is not equal to the sum of these two, okay. This is bigger and the sum of these two is bigger than the modulus of sum of x plus y. That is the idea. So this is the idea for any two vectors. We have to prove whether it is triangle inequality holds good, right? So we know that a vector plus b vector the whole square is, from the previous property, is modulus of a vector plus modulus of b vector multiplied by 2a dot b. This implies what? A vector plus b vector the whole square equal to the same thing here. A dot b vector is what? A vector b modulus of b vector cos theta. So substituting that formula here, we get this, right? So since cos theta is going to be less than or equal to 1, for what? Do you know how this assumption cos theta is going to be less than or equal to 1? Because when there are two vectors, remember that when you have two vectors like this, a vector and b vector, okay, the thing is that when the theta is 90 degree, the value is 0. When theta is 0 degrees, the cos theta is going to be 1. It is going to be less than 1 from here when it is in between, anything in between, okay, until 90 degrees. So anything multiplied by less than 1 means what? Between 0 and 1, some fraction, right? It could be pi by 2 is 0.5, 0.2, something like that. It is going to be very less. So it is definitely going to be less than the other one. So when we take it there, that side, multiply 2 on both sides, some x amount, right? This guy is going to get cancelled. So definitely this portion is going to be, when we take this off, is going to be less than the left hand side, okay. That is the idea. That's why, since cos theta is less than 1, definitely when we remove that, we are going to put this inequality in place. Since this is only going to reduce the value, right? It's going to be less than 1 between 0 and 1 in case of positive angles. So this implies a vector plus b vector the whole square is less than what? Since we removed this cos theta and changed the inequality to less than or equal to, now we got something like this left up. This can be written as how? Modulus of a plus modulus of b the whole square formula. Something like the quadratic equation thing, right? So that is nothing but, if you take the square off on both sides, we have it is less than modulus of a plus modulus of b. Okay, this proves the initial assumption that if there are three vectors, okay, and if this is going to be vector a, modulus of vector a, and this is going to be modulus of vector b, and this is going to be vector a plus modulus of vector b, then this is going to be definitely bigger, right? This entire addition is going to be less than the addition of the individual modulus of the individual vectors. That is the point. That's called the triangle inequality. Let's quickly do example 2.1 where a vector dot b vector, given that a vector is going to be this, b vector is going to be 4i 7k, and there are three things here, right? So there are three different this representations. We have to find a dot b for all these given values. First one, a dot b, just remember, take this one dot product with this one, b vector, right? So we know the vector multiplication, only the components need to be multiplied, right? So we don't have to do the entire multiplication, just multiply the component. So what it was, 1 into 4 is I dot I is 1 into 4 is 4, minus 2 into 4 is my 8, and j dot j is 1, k dot k is 1, what? 1 into 7 is 7, okay, 19. Same way, 2, take this thing, it is 0i in this case, right? You should remember 2i, and so you remember is I is going to be 0i, okay, plus, and in this case it is going to be 0j, okay. So with that in mind, if you do the same thing, apply the same thing here, you get 2. Here what is missing? It's once again 0i. Here the rest of the things are there. So with that in mind, when you multiply 0 into 2 is 0, and the rest minus 2 into 3, okay, no sorry, it's going to be 0, 1 into here, right, 1 into 3, and minus 2 into minus 2, okay, that is what we get here. Hence the answer of this is dot product is 7.